Okay, good evening, everybody. We are going to start our review for exam one. Exam one is going to open at midnight tomorrow. It needs to be submitted by 11:59 on Saturday. Be mindful of the time. Even though the exam will be opening for around 48 hours, remember that you have 120 minutes to complete it. For my students that are part of the SAS program, your accommodations will be incorporated into Canvas. Remember to allow yourself to have the complete time. So for example, if you're one of my students that is going to take it on Saturday, no problem, but be sure to log in 2 hours or your allotted time before 11:59. Because let's say, for example, the student says like, I'm just going to wait to take the exam at 11 because it's going to close at 11:59. What Canvas is going to do once 11:59 comes around is going to shut it down for you. So please make sure that you allow yourself to have your accommodations in a timely manner. So don't start the exam late, because at 11:59, it's going to just close the whole thing, okay? So be mindful of that. So I am missing some students. I have in class tonight 21 or 20 participants. I am missing one person. I don't know. Oh, there you go. We're here. So let's get started reviewing the material for exam one, which is going to be chapter 1, chapter 2, and only sections 3.1 through 3.3 of chapter 3. Let's get started. Great job, everyone. People know what is matter and what's not matter. For the 3 students that didn't select thinking about Kahoot, make sure that you review the definition of what is matter and what is not matter. Remember, in order for something to be considered matter, it needs to have a mass and occupy space, okay? That's by definition. So if the substance or the object that, or, the statement that we talk about does not cover those 2 requirements, then that means that that is not matter. Great. So this is straight out of the gates. These are the students that answer it correctly in the fastest time. Let's continue. Okay, family, what happened? What happened? What happened? Let's go over this. Great for the 2 students that put that astatine or astatine. That is an element that is in the list that you guys are required to know for exam 1. In the study guide, you can see that there's a box with symbols, names of elements that you guys are required to know for this exam, okay? Steel is not a pure substance because it is a mixture of 2 elements, specifically carbon and iron. Organic almond flour, that's another mixture. Just because it has the word organic, that doesn't mean that it is pure. And kryptonite, that is not the name for the element. The element name is krypton, okay? So a pure substance needs to be one of the elements in the periodic table, or it needs to be specifically a compound made out of a combination of elements that are chemically linked to one another, okay? Put a 1 in the chat. So far, so good? Maybe we need to review. Well, this is why we're here. Let's continue.
Oh, fuck.
I say a question.
Oh, sorry.
Oh.
I didn't realize my mic was not muted. Sorry.
Oh, okay, no problem. Great. So for my 5 people that need to review the symbols of the element, make sure that when you look at the study guide, the first page of the study guide, there's symbols and names of selected elements. All of those elements you guys need to be familiar with, okay, for exam 1. So be sure to at least print it, have it, please have it around. Because those are the elements that I'm expecting you guys to know. Let's continue. Excellent. So when we look at the periodic table, okay, let's put in the chat, what is the common name for the elements that live in 8A? What's the name for the elements that live in 8A? Great job. Noble gases. So those are the noble gases. So out of the noble gases, okay, basically we could select. Here we had 4 different types of, or 4 different noble gases that were listed, but the one specifically that is on period 6 is Rn. Rn is which element? It is in the list that you guys need to know. That Vanessa is on, I'm telling you, oh, let's go, Tasia, yes. Radon, okay? That's so important. Not only you need to know the symbol, you need to know the name. Great job, you guys. Let's continue. Put a 1 in the chat if we need to go over this question. Only one person said yes. Do we understand why the answer is the blue one? Why is the answer the blue one? You can unmute yourself and explain it. Only 6 students got this. I don't want any of you guys to miss it in the exam. Why is the blue one the correct answer?
Because it's 700 as opposed to, so 7.00 would be 700 as opposed to 7.0, which is what I put in, would be 70, right?
So it's because of the sig figs. So when we look at the number, the zeros before the 7 are not significant. They're placeholders. There is just telling you that the measurement is smaller than 1. The zeros after the 7 are significant. When you have something in regular notation, which is what we have here, and we change it to scientific notation, you must keep the number of significant figures, because remember, the number of significant figures is attached to the resolution of the instrument. So if you start dropping zeros, then you're saying that the instrument that you're talking about has less resolution than what you're implying in your numbers. So since the normal notation has 3 sig figs, when you change it to scientific notation, that needs to be retained. So yes, we move 7 times from left to right, but because the zeros after the 7, are significant, that's why it needs to be in the coefficient. It is important and crucial for the exam that you guys read the questions and that you understand, okay, when I am going from regular notation, because I believe that you guys know how to convert things to from regular notation to scientific notation. I believe that everybody has the ability to do that. But one step further is you guys need to understand, okay, the measurement that she gives me in regular notation, I need to make sure that I understand how many sig figs are there. So when I change it into scientific notation, it has the same number of sig figs, okay? So I hope that that helps, because these are the common mistakes that now that we're here, I know that you guys are not gonna make them in the exam, okay? So let's continue. There you go, 3 players with 3 in a row. Great job, you guys. Excellent. So the majority of you, when looking at a measurement, will be able to tell me how many significant figures are there. For the few students that didn't get this problem, understand that the 0 after the 9 is significant. The 0 in between the 7 and the 9 is also significant. The zeros before the 2 are just placeholders, okay? So make sure that you review what is the definition of significant figures. Another thing that I want to point out, my expectation is not that you guys can answer these questions in 30 seconds when you are in the exam. Please take your time. The only reason why I made it to be in shorter amount of time is because if you've been studying and reviewing, my hope is that you're able to catch these in a timely manner. There's going to be problems in this Kahoot that I have allotted a minute and a half, but understand that you guys have 120 minutes. Please use them wisely when you are taking your exam. Let's go over this problem. So our value is 242,009. Okay. So if we have to round this to two significant figures, basically we're going to look at the 4 and what is next door to the 4. So since next to the 4 on the right is a 2, what happens to the 2, the 0, and the 9? What happened to all of those digits? Let's put it in the chat, or you can unmute yourself. What happens to the number 2 that is on the right and all the other digits after the 0, and the 9? What happens to it? Thank you, Maria. They turn into zeros. Exactly. Since they turn into zeros, then the value when we round this is going to be 240,000. 240,000, when we put it in scientific notation, we have to move the decimal place 5 times from right to left. Thus, that's why the answer is the one that is in yellow. Okay? So if you got this incorrect, hey, put a 1 in the chat if now it makes sense why the answer is the yellow one. I just want to make sure that these little things, you know, I shouldn't call them little, that these concepts do not catch you off guard in the exam. Okay? I believe that you guys can do well in the exam. Let's continue. Temperature conversions. Excellent. So I can see that a large number of you guys, at least 2/3 of the class, is able to do temperature conversions. When it comes to temperature conversions, please look over your notes, and specifically, this is chapter 1 material. Slide 41 in chapter 1 material is where your equations for temperature conversions are. Make sure that you have that in handy, okay? Because you will be doing that in the exam also. Let's continue. Okay, so let's go over this problem. Give me a moment for me to copy the problem down because it is important that you guys know this for the exam. Give me a moment. So here we have 34.2 minus 25.258, close the parentheses, times 0.354. So for a moment, let me stop sharing Kahoot and share my iPad. Great. So we can see that here, the first thing that we're going to do is the parentheses. And from the parentheses, we're going to take 34.2 and we're going to subtract it from 25.258. My calculator display coming out of the parentheses is 8.942. Put a 1 in the chat if that part makes sense. Just want to make sure. Excellent. Now, I'm going to utilize my highlighter tool because we are doing subtraction in the parentheses. What am I looking at? Significant figures or decimal places? You can put SF for significant figures or DP for decimal places. Excellent, decimal places. So how many decimal places do I need to pay attention to in that digit 8.942? Great. So I'm going to highlight or underline whatever you need to do up to that first decimal place. Let me underline it. Now I'm going to utilize all the numbers. So I'm going to use my calculator display of 8.942, and I'm going to multiply that times 0.354. Okay. From there, times 0.354. From there, I get the following digits: 3.165468. Put a 2 in the chat if so far makes sense. Great to see those 2s. Now, the last operation I'm doing is multiplication. So what do I pay attention to in multiplication? Significant figures or decimal places? Thank you guys in the chat. Exactly. Significant figures. So when I look at the significant figures on this number right here, how many do we have? Let's put it in the chat. How many sig figs do we have? Great. 3. Now let's look at what I highlighted and underlined. How many sig figs do we have there? Great. Only 2 sig figs. So when I have this number, I need to round to 2 significant figures. So that means that 3 is significant, the 0.1 is significant. So I'm going to look what's next to my 1, since it's a 6. Then when I round this to 2 significant figures, the final answer is 3.2. Okay? Questions about this problem?
Why are you still using you're still in the equation instead of just using the 8.9 and then moving forward to the multiplication part? You're using the whole thing. Is just because of accuracy?
Exactly. It has everything to do with the laboratory. Everything
Okay.
to do with the laboratory. So what happens is that when you use instrumentation, okay?
Mhm.
In instrumentation, you're going to have resolution, which is the digits that we can see. When you're doing mathematical operations, the thing is that one of the things that to date you guys haven't calculated in the laboratory online is what is called percent error. Percent error is what we utilize in the laboratory to compare known measurements to the ones that you get in the laboratory. So for example, if you were doing a density experiment in which you know the density of a particular metal, and then I give you just different metals and you're trying to compare it to what is known, you can tell, oh, this is me getting the density in my hands. Let me compare it to the real value. And percent error will tell you, how well are you doing it? Going back to this, if you're using different instrumentation, the reason why we don't round is because then you're affecting the resolution of the instruments that you utilize throughout. And for example, when you're doing things like percent error, there's going to be many digits that may be coming from the known measurements for density because of the instrumentation that was utilized, versus when you're comparing your digits with the instruments that you use in your laboratory, the resolution may not be the same. So that's why we need to keep track of the digits throughout, apply sig figs, because again, whenever it has to do with measurements, resolution is what we're affecting if we start rounding too early. Does that make more sense?
Yeah, thank you.
No problem. Let's go back to Kahoot. So again, when it comes to measurement, you guys, is always the laboratory. That's the application of it. Okay, let's continue. So this is a clinical problem, okay? When it comes to clinical problems, I understand. Maybe a minute and a half was not enough. Let's go over it in detail to make sure that everybody understands how to do a clinical problem. The clinical problem in the exam is a numerical entry, which means that you're going to do all the math and you're going to enter the final answer. And out of the 10 students that submitted answers, only 2 got the right answer. So I think that we should at least review it. Let me just write the information on my side. So we have the doctor's orders. And the doctor's order is 1.2 centigrams per 1 kilogram of the medicine. My patient has a particular weight, which is 125 pounds. Then my clinical factor, which is what is the medicine in hand, is 100 milligrams of the medicine for every 2 milliliters of the medicine. So let me share my screen. So this is the information that is given in the problem. Whenever we have a clinical problem in which we need to take into account the weight of the patient, what is the first conversion that you always do? Thank you guys, exactly. We need to change that weight from pounds to kilograms. So I write 125 pounds. And to do my conversions, on top, I'm going to put 1 kilogram, 2.20 pounds in the bottom. Great job. Thank you for the comments that I see on the chat. So this is always the first step. Always, 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 always. Now, the next thing that we have to think about is, well, the doctor tell me that I need to dose this person in a particular amount. And then the medicine in hand, which is what I have in the clinical factor, I have to make sure that my doctor's orders units and my medicine units match. The bottom part there of 1 kilogram, that just tells you that that's per kilogram how much medicine you need to give it. Okay, so don't be confused by, do I look at the centigrams? Do I look at the kilograms? No, the kilograms is going to be what cancels out with that first conversion that I set up. Okay, so we can see here that they do not match. The doctor's orders and the clinical factors do not match. So what do I need to do? I need to match them. You can change your clinical factor to match the doctor's orders, or you can change the doctor's orders to match the clinical factor. Okay. My preference is when I deal with these type of problems that I match my doctor's orders to my clinical factor. So what that means is that I'm going to convert 1.2 centigrams into milligrams. So how many milligrams in 1.2 centigrams? This is a metric to metric conversion. You can use the number line method. How many milligrams in 1.2 centigrams? No, the answer in the chat right now, that is if it's decigrams. Do I need to explain the number line method? Put a 1 in the chat. Using the number line method, I have 1.2 centigrams. I need to convert this to milligrams. What is given is where I start, centi. I move to the amount where I'm going, which is milli, here. So what does this mean? That's the same thing I'm going to do with the decimal place. Move the decimal place one time from left to right. The number line is on slide 35 and also slide 36 in the notes. So that's the first time that I show it to you guys. This is slide 35. I'm using the one that I copied down in slide 36 to show this. Thank you, Marisol. Exactly. So in 1.2 centigrams, there's actually 12 milligrams. Okay. So going back to our notes, taking that into consideration, then we know that 1.2 centigrams is actually 12 milligrams. So this is the same thing as saying 12 milligrams per 1 kilogram. It's the same thing. So now that our doctor's orders, we have it in a unit that matches our clinical factor, we can continue the problem. So now I'm going to use my doctor's orders. Remember that you cancel diagonally. So what does that mean? That because pounds cancel with pounds, I need to cancel kilograms. So I'm going to use my doctor's orders now. I'm going to do in the bottom 1 kilogram, because I want to cancel the kilograms that are in the top, and then I'm going to put 12 milligrams on top. Kilograms cancel. Now I have milligrams. The last portion of this is using your clinical factor to find the final answer. Where do milligrams go? On top of the line or on bottom of the line in the fraction? Excellent job, on the bottom. So here I do 100 milligrams. And on top, I do 2 milliliters. Because what my clinical factor is telling me that every 2 milliliters that I extract out of my vial are going to contain 100 milligrams of this drug, okay? When I go to cancel units, now milligrams cancel with milligrams. And overall, I get milliliters, okay? So I put it in my calculator, 125 times 1 times 12 times 2. And I'm going to divide that by the multiplication of 2.20 times 100. I get the following digit, 13.6363, so on and so forth. I mentioned, and similar, in the exam, you will see that I tell you how many sig figs I want in my final answer for your clinical problem. So I need to round, according to my instructions, this. I'm going to round it to 1 sig fig. So if I round that to 1 sig fig, 1 is significant. I'm going to look next door. This is a 3. And in order for us to keep our place value, our quantity, that 3 needs to turn into a 0. That's why the final answer is 10 milliliters. Put a 1 in the chat if at least this clinical problem, now that it has been dissected, makes a little bit more sense. Great. Let's go back to Kahoot. Don't worry about it. When it comes to the exam, you guys are going to have 2 hours. What I'm trying to do is that because this class only meets until 7:20, and as you can see, we have only done 10 questions out of the 30. Just breathe. You got this. You know, nobody's going to be looking at you. Just make sure that you're in a place where you feel comfortable, that you're not stressed, that, you know, if you have a family, everybody's asleep, so you can just have your 120 minutes. You got this. Let's continue. We're only a third of the way. Density question. Put a 1 in the chat if we need to go over this one. This is a similar to a problem that we did in class. I don't want you guys to be discouraged by the review. I only see 2 1s. I want you guys to understand that this is to the level that I expect you guys to know this material, because this is to the level that we study it. Exactly. So when it comes to this question, we're doing a density, okay? Since we are studying the volume, we need to make sure that we know what we are dividing. And just like it was put on the chat, thank you, Marta. If we're studying volume, volume specifically is going to be not density over mass, okay? Let me just share my screen. Let me just write this. So density is 3.52 grams per milliliter. Volume is what we're finding. Mass is 15.1 grams. We're finding volume. So we went over the different equations. Here we're trying to find volume. Since we know that density equals mass over volume, okay? Volume, the equation is that volume specifically is going to be mass over density. Okay, those equations are in the slides. So we are given mass, we are given density. 3.52. Let me rewrite it. Mass, that's 15.1 grams. We're going to divide it by 3.52 grams per milliliter. 15.1 divided by 3.52. This is 4.29 milliliters. Why do I know it's milliliters? Because I have to look at my units. Grams cancels with grams, so what's left is milliliters. The question asks, what is the volume, but in liters? So if we're going from milli to liters, how many times do I have to move that decimal place? 3 times, thank you. In which direction? To the left. Great. So when we look at this, and we go back to our Kahoot, the scientific notation for my answer is going to be the 1 times 10 to the negative 3. Because again, the question is prompting me to do liters. This is what I mentioned to you guys a few moments ago. Please read the questions in the exam. Don't just look at the numbers, plug them in the calculator, and select the answer that shows up in the calculator right away. Let's make sure that we read what the question wants us to answer, okay? Let's continue. Great. Remember that as part of the study guide, you guys need to know the different terms for phase changes. And remember that phase changes are always physical changes. And freezing is when you go from liquid to solid. Remember that when a substance undergoes a chemical change, we are going to have a brand new substance that is going to have its own physical properties and chemical properties. Cutting paper that was in the lab that you guys just did, that still retains the characteristics of the original substance. Just cutting paper doesn't change paper. When solid dry ice changes into gas, that's a phase change. When boiling water forms steam, that's just a phase change, okay? So the only one is the tomato ripening. Next question. So here we were looking for the atomic mass of sodium. What is the atomic number for sodium? Let's put it in the chat. What's the atomic number for sodium? Great. What is the group number for sodium? Group number. Excellent. Make sure that you're familiar with the periodic table, that you know where certain elements are, specifically those elements that I mentioned to you guys from about 2 weeks ago. Make sure that you know these elements, because it's important that you know where they at, so you are not like searching around the periodic table. Where is this? What does she mean? Okay, make sure that you're familiar with that. Let's continue. We're halfway through the quiz. Great. So for the students that answered, you know that the that thallium is element 81 with a symbol of capital T followed by the letter L. Okay. Again, that's just another element that is in the list that I gave you guys. If you need a reference, we're already on chapter 2 material. Great. So the person that answered false, you are going to, now you know the electrons are outside of the nucleus. That is in a table for chapter 2. What slide is that? That is slide number 2, where that information is at. There you go, 3 players with 5 in a row. Great job, you guys. Okay. This is isotopic notation. What is the number that is on the top in isotopic notation? What does that represent? Let's put it in the chat. Great, the mass. What is the number in the bottom? Great job, atomic number. So remember, atomic number is the number of protons. Mass is protons plus neutrons. So if you're trying to find the neutrons, is that top number minus the bottom number. And the only one of these that have 10 as the answer is going to be the yellow and the blue. All we have to do is just subtract that top number to the bottom one to get the neutrons. Okay? There you go, 3 players with 3 in a row. Great job. Let's determine neutrons and protons. So this is another way that we write isotopes. We put the name of the element and then the number 74. What does the number 74 represent, you guys? Let's put it in the chat. What does the number 74 represent? Thank you, Maria. Thank you, Katie. Thank you, Dominique. The mass, okay? So here, because you know the name of the element and you know the mass that was given next to the name of the element, we need to derive the atomic number for it. So what's the atomic number of selenium? Great, 34. So that means that my protons are 34. How do I get my neutrons? 74 minus 34. Okay, that's why we have 40 neutrons. Let's continue. So this is part of the definitions that are on the slides for chapter 2. Make sure that any definition that you have on the study guide, that you know what are the terms that are utilized in the slides in order to define them. And as you can see, that's the definition for radiation. Let's continue. We are 2/3 of the way. So again, another of the definitions, make sure that you look through the slides, that you watch the videos that I posted last weekend for the material in chapter 2. The definitions are part of the slides. I uploaded the notes that I took while I was recording the videos. Make sure that you understand the different forms for nuclear radiation. Let's move on to the last 10 questions. Put a 1 in the chat if we need to go over this question. I have another practice problem like this after this question. I want to make sure that you guys get this in the exam. All of this is part of the material that is, again, in the videos that I posted to you guys last weekend. Let's go over it. So the information that we have here is that we have potassium 37 going to argon 37, okay? As I discussed in the previous problem, when we have the name of the element next to a digit, that digit represents the mass of that isotope, okay? So if I do isotopic notation on this isotope is going to look like K37 on the top. What number, if that is potassium, do I put in the bottom? Thank you, Guillaume. 19. For those students that are like, thank you, Vanessa, excellent. For those students that are like, where did that 19 come from? The atomic number, you guys. I'm just converting that notation in words to isotopic notation. That's the only thing that I'm doing. So when I do this to argon, okay, I put AR, see that it is 37, the 37 puts on the top. What number am I going to put in the bottom for argon? Thank you, Marisol. 18. So when I compare this and this, what's the difference between the two of them? What's the difference between those two isotopic notations? Other than the symbol. Great, I see great observations on the chat. We have a different atomic number, which means that we have less number of protons. So that means here that whatever particle came off, okay, is because we changed one proton in the system. Great. when we change, just like Katie said on the chat, when we change a proton to a neutron, but understand that in the context of this, because that neutron is going, or that positron has zero change in the mass, we are going to keep that mass. Okay, so if you have a change in which you have a larger atomic number, you keep the same mass number, but then you have a lower atomic number, that's how we produce a positron. Okay, so a positron emission is when we have a proton changing to a neutron. A beta particle is where we have the neutron changing into a proton. Okay, let's do one more problem like this, just to solidify this concept. Let's do the next problem. Let me just write here, polonium 210, lead 206. Okay, let's go over this one. Let me make this 210 more clear. So, what is the symbol for polonium? Great, PO. Again, it's in the list of elements that you guys need to know for the exam. So PO, 210 on top. What number do I put in the bottom? Excellent, 84. This is going to be changing to lead. What is the symbol for lead? Great job. PB, on top I'm going to put 206. What is the atomic number for lead? Great, 82. So did we have a change in atomic number? Yes or no? Great, you guys can identify that. Did we have a change in mass number? Great. We can see that the mass number changed by 4, right? We can see specifically that our atomic number changed by 2? What is the only particle out of the ones that we studied that looks like the nucleus of helium? Great, an alpha particle. Since it has, you know, that helium-like nucleus, it makes sense that we have the change of 4 and then the change of 2, okay? Because this is an alpha particle. Questions on this type of problem? I want to make sure that this doesn't catch you off guard in the exam, you guys. I know that class ends at 7:20, but if people are willing to stay, I'm willing to stay here also. I will continue to show the questions for the Kahoot. So if you have other commitments and you want to log out, understand that I will be posting the video. If you're willing to be here, to stay, I'll stay here with you guys, okay? Let's move on to the next question. Any questions when it comes to these, again, identifying the type of nuclear radiation just by looking at isotopic notation? Because I want to make sure that you guys get that in the exam. Any questions when it comes to that?
Yes, I have a question. That table that I found on page 59 in the book, so if it has a charge like +2, it's always going to be an alpha?
So when it comes to alpha emitters, let's just put it that way. Let me go to what I want you guys to look at when it comes to this. Let me just share. So this is from the slides. Or actually, let me go to the ones that I utilized. So these are from the slides from the video, okay? So as you can see here, like in the example that we have from the video that I posted, whenever you see that there is a change by 4 units in the mass, but 2 units less in the atomic number, okay, then you know that it's an alpha particle that got released, because alpha particles are similar in their nucleus like helium. So as you can see in the example that I gave on the slides, we have uranium. Uranium, along with the alpha particle, it now forms the element thorium. And then what do we see? Look at the change in the mass. We reduce by 4 the protons, in other words, the atomic number reduced by 2. So if you see that change of 4 units in the mass and 2 units in the atomic number, don't even think about it. That is an alpha particle, okay? Here we have an example of when an unstable nucleus releases a beta particle, okay? Here we have the example of carbon-14 nucleus, okay? Let me just zoom in. Carbon-14 nucleus. When a beta particle is released, what we have is that a neutron turned into a proton. Now, understand that when that beta particle is created, you're not going to see changes in the mass number, okay? You're not. What you're going to see changes is just that now we went from 1 atomic number to the next highest. We went by 1 in the atomic number. So when the atomic number from the beginning to the new atom that gets formed and then the release of the particle, you see that there's an increase by 1 atomic number. So we went from carbon 14 to nitrogen 14. Okay, so far so good. Put a 2 in the chat if the first 2 nuclear radiation emitters make sense. Good. Let's move on to the next one, which is the opposite of beta, which is the positrons. So look at the positrons. In the positrons is the reverse of what we just saw in the beta particle. And this is what we had in the Kahoot. Notice that there's no change in the mass number. What change? Our atomic number. If it goes down by 1, that's a positron emission. And it's just from the fact that the positron, as you can see, has a mass number of 0. So we're not changing the mass, okay, of the new atom that gets created once that positron is emitted. Okay, put a 3 in the chat if 1, 2, and 3 make sense. And the last one, which is gamma rays. Okay, gamma rays are interesting because gamma rays typically come along with other emissions, right? So here I gave you guys the example of this radioactive cobalt. Okay, so this isotope of cobalt is radioactive. Okay, so when we look at this, we'll say like, oh, cobalt change from cobalt 60 to nickel 60. But in addition to the gamma rays, this released a beta particle. Okay. So gamma rays is the only one out of the 4 that you guys need to know for the exam, that for the examples that we have seen so far, it doesn't get released by itself. It goes along. In this case, I just show you guys an example with a beta particle, but gamma rays always go along with other radiations. Okay. So it is in the notes. So when you have this in this exam, just make sure that you're like, okay, from my notes, what am I looking at? Did the mass change? Yes or no? Did my atomic number change? Yes or no? And based on that, that's how you resolve those questions. So it's a little bit of more analysis, but that's why I brought it up in the Kahoot. So when you guys observe those questions, then you're not taking off guard. Like, I want to make you guys be ready for your exam. Okay. So let's just finish up the last few things that we need to review in chapter 2. Let's move on to the next question. We're already on chapter 3, the contributions of Rutherford. Excellent. So Rutherford did a particular experiment. What's the name of the experiment that Rutherford did?
Gold foil.
Excellent. So the gold foil experiment was the one that gave insight into discovering the nucleus in atoms. Okay. The blue one says experimentally showed the existence of atoms. Who did that? Who showed that experimentally atoms were what matter was made out of? Who showed that experimentally?
Was that Democritus?
Democritus gave the idea, but 2,000 years later, somebody was the one that actually said, yes, let me show experimentally. So Democritus put the idea.
Dalton?
Yes, Dalton, great job. Who was the one that showed the existence of electrons? Who discovered electrons?
I think it was Thompson.
Yes, J.J. Thomson. And who created the first classification of the periodic table? Thank you, Vanessa. Dmitry Mendeleev, the Russian scientist, okay? So all those dudes, you need to know what they did and what's their contribution. They are throughout all the chapters, okay? Let's continue. We have about 7 more questions to go. There you go, Daisy, you got 3 in a row. Electron configurations. Count and add the superscript. Count the superscripts, that gives you the atomic number. Only 1 person answered? 2 people answered, 3. So, as I showed you guys in the video, if I give you the electron configuration of something, you're going to say 2 plus 2, that's 4. Plus 6, that's 10. Plus 2, that's 12. Plus 6, that's 18. Plus 2, that's 20. Plus 5, that's 25. And then the atomic number for element 25, that's manganese. Okay? So that's a quick way to know what is the element given by a particular electron configuration. Valence electrons. Is the number before the letter in the group. Great. Bromine is a halogen. That means that lives in 7A. Since it lives in 7A, it has 7 valence electrons. How do we illustrate valence electrons? How do we illustrate valence electrons? How do we show them?
It's when we do the Lewis structures.
Exactly, the Lewis structures. So how do we show them? What do we use to symbolize them?
The dot, like the dots. around
Exactly,
the-
dots.
the
So how many
element.
dots are we going to put around bromine? Let's put that in the chat. How many dots? Great, 7 dots, because that's the number of valence electrons in bromine. Look at the list. Who's gonna make an ionic bond? So when we look at pairs of atoms and we're looking for them making an ionic bond, what are the 2 things that when combined make an ionic compound or an ionic bond? What are the 2 things? Great, metal, non-metal. So where can I find metals, you guys, in the periodic table? Where is that? You can unmute yourself if you want to. Like by now, there's only 11 of us in here. Where are the metals? Where do they sit in the periodic table? There's group numbers attached to that. Where do I find metals?
Group 1 and 2.
Group 1 and 2, that's good. There's a few more areas. So grab group 1 and 2. Where else?
In group B,
Group B, great, Vanessa. Where else? Group 1 and 2, group B. Where else do we have metals? One more group.
3A.
3A, excellent. But in 3A, what are the elements that are metals? Because in 3A, we have a little bit of everything.
It's Al, Ga, and In.
Excellent. So aluminum, gallium, and indium. Okay. Now,
Not TL,
huh?
not TL. Volume.
So when it comes to thallium, it's just that that is also a transition metal, but those, because it's in the 80s, technically, to be honest with you, I'm not very familiar with the chemistry of thallium. Since it is there, it should only have one charge of 3+. It makes one type of cation, but we typically don't talk about it because that's like more advanced, like general chemistry. So we don't do that one, but
Okay.
it should be. And to be honest, I have never worked with thallium in my years of training. Now, around the area of thallium, there are 4 elements that are also variable charge with the crew that you guys just mentioned. Again, 1A, 2A, 3A, group B. Then tin, antimony, so elements 50 and 51. Lead and bismuth, elements 82 and 83. All of those form cations. All of those by, different ways. Some are type 1, which means one type of charge. Other ones, multiple charge, okay? Now, when it comes to the pair, right? So you guys said metal, non-metal. I agree. Non-metal can form a negative charge, okay? So out of the ones that you guys need to know for the exam, which group numbers are you concerned with of making anions? Which group numbers for non-metals make anions? Great job. Thank you, Katie. 5A, 6A, 7A. Now, there's another group of anions that I gave them to you guys in a table. Great, excellent. The polyatomic ions. So remember, when it comes to ionic compounds, it's basically, I need something that is a cation and something that is an anion, okay? And it is crucial that you know how to identify them, so you know how to write their chemical formulas, so you know how to write the correct overall chemical formula and name. Let's just do a few more. No problem. So what happens with 4A is that 4A it's very diverse, because in 4A you start with carbon. Carbon is a non-metal. Carbon makes covalent bonds. Then you go into silicon and germanium in 4A. Silicon and germanium, they make covalent bonds too. Then you have tin and lead, they make ionic compounds. So what happens is that in 4A, we do not have a trend, because all of the elements in 4A have different types of bonding. So that's why we don't talk about them, because they don't have a trend just like the other ones, like 1A, 2A, 3A, and then 6A, 5A, 6A, and 7A. That's why. That's a great question. Let's move on to the next question. Chemical formula for a compound that is made out of potassium and nitrogen. So when it comes to this, because I see that two students didn't get it, potassium has a symbol of K because potassium lives in group 1A. It's going to be positive 1. Nitrogen, because it lives in 5A, it has a charge of negative 3. The value becomes the subscript of the neighbor. That's why we have K3N. Okay? Because the subscript that we see in potassium is what used to be the charge in nitrogen. Exactly, we switched them. So the charges become the subscript. So the charge of 3, not with the value, just not with the symbol of negative, just the value of 3. That's going to be the subscript of the potassium. The 1 in the potassium is the subscript of the nitrogen, but it's just that 1 is omitted. And since 1, we don't write it, that's why there's no number next to nitrogen. We have 3 more questions to go. Good job, Vanessa, 3 in a row. Lead 2 sulfite. Let me just, do people have questions when it comes to naming anionic compounds? Because I'm willing just to finish the Kahoot quiz and then just answer questions on that. Because I see that people are not answering. Do people have questions on naming? No problem. So for this one, the name tells you lead, Roman numeral 2, and then we have sulfite. Okay, so what is the symbol for lead? Let's put it in the chat, you guys. Great job. Now, the Roman numeral tells me the charge of it. Now, when you have an ionic compound, you guys, don't even think about it. The name of the first element is always your cation. So since I have a Roman numeral of 2, that's what lead 2 looks like, okay? Then we have sulfite. Let me give you a trick with this. If the next word ends in ITE, like this one, or it ends in ATE, go to the polyatomics. There are only 3 polyatomics that do not end in ATE or ITE, and you just need to know them: hydroxide, peroxide, cyanide. The rest of the compounds in there are going to end in ITE and ATE. So if you see something that ends in ITE, just like this one, sulfite, you run for the polyatomics, okay? Sulfite, and it's SO3, and its charge is 2 negative. So When we have a pairing of a cation, as you can see, 2+, and the anion is just the opposite, they just cancel each other. So overall, when we have a scenario like this, we cancel, because you have 2 positive on one side, 2 negative in the other, and our final answer is just going to be putting all those letters together, PbSO3. That's your final answer. We are going to do that when we have +1, -1, when we have +2, -2, or if we have +3, -3. Questions?
Yes, what were those 3 that you said that won't fall into the ITE, ATE, peroxide, cyanide, and
Peroxide, cyanide, and hydroxide.
hydroxide? Thank you.
Hydroxide, those are the only ones that are polyatomic. That do not end in -ite or -ate. Understand that if something is, it has the stem of an element like chlor, fluor, brom, iode, nit, and it ends in IDE, that's a nonmetal. Phosphide, nitride, oxide, sulfide, fluoride, chloride, bromide, iodide. So just keep that in mind. Like, as long, this is why I encourage students that when you're taking my exams, because I'm expecting open notes, organize your notes because before you sit down and do the exam. Because if you don't have organized notes, the issue is that you will be scrambling through notes and then the time is going to pass by. So my advice, if you guys haven't organized your notes for the exam this week, go through the study guide. It is an outline. Organize your notes based on that, because that's all of the information that we have done. Is the majority of it. There's barely few topics that I think I didn't include just because maybe, you know, in passing the slides, I didn't write them in, but the majority of the content of the exam is in there. Organize your notes when you take the exam. Let's just finish up the last few questions that we have.
I have a quick question.
Yeah, go ahead, Daisy.
The peroxide, hydroxide, and then I don't know how to pronounce the last one. What did you say that those were called again?
Those are polyatomic ions. So whenever we're naming, and you can see here, lead-2 and sulfite. So if you're saying, okay, where is sulfite? I don't know where sulfite is because it ends in ITE, run for the polyatomics because that's where you're going to find it.
Okay, that makes sense. Thank you.
Let's just finish the last 2 questions. We're trying to determine the name of MgF2. So if we look at MgF2, when you're given the chemical formula and you need to find the name, let me go back to my slides. Oh, let me go back. Slide 18. That's the key for naming ionic compounds. Slide 18 on chapter 3. So for those of you that have your notes with you, on slide 18 for chapter 3, you see that it says naming ionic compounds, right? So if I go by the numbers of the rules, which is 1 through 5, for naming magnesium, which rule am I using? 1 through 5. Which rule am I using to name magnesium? Great. I like to see those twos in the chat. Rule 2, great job, you guys. Because rule 2 says cations of group 1A, 2A, 3A, zinc, cadmium, silver, we just use the name of the element. So that's why we just use magnesium. Now, we have paired with magnesium just fluorine. So what rule tells us how to name fluorine? What rule tells me how to name fluorine? Again, we're on a slide 18. Okay, I see an answer. That's correct. I think everybody to go through that. Rule number 4. Rule number 4 says anions of nonmetals are named by replacing the ending of the name of the element by the suffix IDE. I gave you a table. Now you have to make sure that that table, you know how to spell it correctly. It's fluoride, F-L-U-O-R-I-D-E. The green one was not correct because that says fluoride. It's not fluo, it's fluo. Okay? Let's do the last question. Okay. So here we have a compound, okay? This is how we break down the name of this one, okay? So when we look at the cation of this system, which is PB, which rule tells me how to name PB? Let's put it in the chat. Again, slide 18 from chapter 3, what rule tells me how to name atoms like PB? Great. Thank you, Katie. Number 3, because PB is a transition metal. It says cations of group B, tin, antimony, lead, or bismuth. We need to break the chemical formula into ions. Okay? So what that means specifically give me a moment, is that if we have PB, ClO3, what I mean with rule 3 is that we're going to break it into ions. So we are going to make this subscript back into the superscript of that. We're going to make this subscript that is implied but not written go back and be the superscript of that. Why do I need to do that? Because that's where they used to live before they became a subscript. So when I break this into ions, I'm PB plus 3, ClO3 negative 1. So where do you find ClO3? In the polyatomic ions. This is chlorate. When we have a polyatomic ion as part of the chemical formula, we just use the name of the polyatomic ion. This is a type 2 metal, meaning it has variable charge. When we are using for naming, we're going to put the name of the element, lead, in a Roman numeral in parentheses that expresses the charge of that element. So the name of this compound that at first we had it up here as PB parentheses ClO3 outside parentheses 3, the name of it is lead 3 chlorate. Okay. So with that, that is the end of Kahoot. You can see here the positions. Any questions that you guys have that I can help you with in preparation for the exam? Any questions that you wanted to ask in preparation for the exam? So when it comes to the test has multiple choice questions, match terms, numerical entry. So there's just a variety of questions, true or false. There is no short answer. And like I said in the announcements for the class, is 15 items per chapter. So you will see numbers 1 through 15 is chapter 1. Numbers 16 through 30, that's chapter 2. Number 31 to 45, that's chapter 3 material. So when you study, you know the jump from chapter to chapter, because I broke it down like that. It should not be a surprise that all of a sudden, when you finish physical properties and chemical properties, the minute that the questions turn into atoms and electrons and protons and neutrons, counts and all that kind of stuff, you know that you're in chapter 2. And specifically, once you start question 16, chapter 2 material. Once you start question 31, chapter 3 material. Question 1, chapter 1 material. No problem. I'm here for you guys' success. I just wanted to make sure that the questions that I showed you in the Kahoot quiz are going to be a reflection of my expectation of the knowledge that you're going to show me in there. These problems are things that we have done in the worksheets, that we have done in the slides. So I really hope that this review was able to help you guys to at least understand the content that you guys are going to see in the exam. Any other questions? You're welcome.
Thank you. Good night.
No problem. Good night.
Thank you.
You're welcome.